This molecule you are seeing is called chloroxylenol. It's one of the formulation in the disinfectant liquid called Dettol. It's quite common nowadays. Sanitation is the word mostly used. It's produced in large quantities, and this liquid is used by a large number of people nowadays. So let's see how we can make it, like the retrosynthetic kind, but it's a small molecule, not a big one. Therefore, it's easy. We don't have to uh, do bond breaking, making, and all. Just simple thing. So I see three molecules in it, like a phenol or xylene or chlorobenzene. But we can't use phenol or xylene because look at the positions. That it is we have to use a metaxylene, and OH will go meta to the CH3, which is which is difficult to happen. Like CH3 is auto para directing and OH is also auto para directing. If you take a phenol, you can't substitute the CH3 in the meta position, and if you take the xylene, you can't substitute the OH in the para position. You can't do substitution of OH first of all. That's a different story, but the positioning is not good. Therefore, the only way to make this is by using chlorobenzene or using benzene, then chlorinating it. First, you need to do chlorobenzene. At first, I thought after chlorobenzene we have to nitrate it in the para position. At first, I thought we better take nitrobenzene and doing the chlorination, but it's quite difficult because when you substitute a nitrate group in the ring, it's going to deactivate it. So it's better to use a chlorobenzene than nitrating it. But anyway, you get the same product. We need a product which have which have nitro group and the chloro group para to each other. So we get it. We take the chlorobenzene, we get the nitro para substituted chlorobenzene. Then we have to do Filcav's alkylation at the two positions of the chlorine ortho to the chlorine, which is also meta to the nitrate. Therefore, even though nitrate is deactivating, chlorine is slightly activating. With vigorous conditions, we can make these substitutions, or we have to methylate the ortho positions of this chlorine. Then the final reaction is we have to reduce the nitro group to amine, and then we have to make the diazonium salt by treating the amine with NO sodium nitrite and HCl, and further we have to treat it with water. If you heat the diazonium salt with water, you get the phenol. So that's how you're gonna make you get the OH group in that and diazonium position. So that's how you're gonna make this thing. And this is not, I think this is not exactly they gonna synthesis this. While thinking about it, I had other ideas also. Like instead of using a chlorobenzene, they can use an acetanilide and then alkylating the acetanilide, and after that substituting the chlorine, and finally the acetanilide is converted to an amine or OH like that. That is a very easy reaction with less number of steps, but I don't know how we gonna convert an acetanilide to an amine. It's okay to convert amine to acetanilide by treating it with acetic anhydride, which is also not possible in a large scale industry because acetic anhydride is banned. It's a regulated chemical because they used for the acylation of morphine to heroin. The acylation, only difference between the morphine and heroin is it's acylated in instead of one, it's acylated in a couple of positions. Therefore, I had that other idea also for making this molecule, but the only problem is I don't know how to convert the acetanilide to OH, how to get the OH in the anilide position, like acetamide position. I don't know how to do that. If you know it, just type in the comment section. And for this molecule to be produced in large scale, I don't think these two are the reactions. These two are the kind of design they're gonna make. I think they must have gone with some other design. That's what I really want to know. uh, after coming out of college, this is the what thing that I want to know what they do when they go for a big large scale synthesis of this chemical, or they really do using the reactions which we studied in our college, or they using some unknown reactions. Look, even in MSc we get some other type of conversion of functional groups which are not very common. What the design which I told previously, or just a common way of functional group interconversions. But I think in industry in a larger scale, I think they're going to make new catalysts to make a different kind of conversions like Aston led to, which how we can go from that to that. I think they could have thought in this way, and they're definitely going to make a different kind of reaction than what the two kind of synthesis I told. So let's see what your thoughts on this, and I'm gonna make all kind of retrosynthesis for all the known molecules in the future, and let's consider this as episode 1, and like, share and subscribe.